Hi ladies and gentlemen, this is Mr. Green again, and this is another in my series of lessons for geometry. Where are we at? Well, we're looking at Unit 4 right at the moment. Unit 4, we're dealing with circles and lines, okay? So we've already looked at chords and arcs, and we've looked at tangents and chords and secants, and so we're moving forward in the unit into the next topic. Don't forget, look at corrections. Make certain you can correct, that you know how to correct, and that you have corrected all the things that you can, because it really will help your grade, and it will help in this semester. Trust me. Due dates. We're getting close to having things closed up, and I don't want you getting having zeros permanently in your grade book, so you want to make certain you get them all taken care of, okay? So, where are we at? Whoops, that's in the wrong place, and didn't want to do that one. Okay, so I want to draw an inscribed angle for you. An inscribed angle. Inscribed. That means I'm going to start at some point on the surface of the circle. I'm going to go all the way across the circle to the other side. That's a chord that I just drew, right? Okay? And then I'm going to go from that chord, from that vert point there, and go across to the other side of the circle with another chord. So two chords going across the circle, okay? So if I started at point A, went over here to point G, and then went back down here to point D, I found chord A, G, D. That is what chord I just, or that's what angle I just drew right there, was angle AGD. Now the arc that was inscribed by this was arc AD. What do I mean by an arc that was inscribed by this? Well, this part of the circle over here that was inside of the angle, that the angle's edges kind of outline for me, that's the inscribed arc. Okay? This is called an inscribed angle. Okay? That's what we mean by drawing an inscribed angle. Inscribed angle, arc that's inside of that angle. Okay? So, looking at this, what would be an inscribed angle in this figure? Well, I just told you it has to be inside of the circle, right? So it's not going to include point F out here, so I'm going to mark that one out. Okay, it's got to go, and the vertex has got to be on the edge of the circle. So it's not going to be that one there, and it's not going to be that one there. Okay, let's see here. It's either going to be something with A or with B, right? Well, that means the edges of the angle have to go all the way across in a chord. Well, the edges from B going through E, that didn't go all the way across to the edge of the circle. It's not a chord. From B to C is not a chord. B to D is a chord, but that means B isn't the vertex. That makes D the vertex. So my inscribed angle in this situation would be A, D, B. How'd I get that? D had to be my center of my angle, my vertex of my angle, because I've got two chords, AD, there's a chord there, and DB, there's a chord there. Okay, those chords going across intersected at point D, that became my inscribed angle. Okay, moving forward. This theorem is one I talked about when I did the first lesson. I made sure you guys knew that if I had an inscribed angle, this angle, if it's x, then this chord is going to be twice as big. It's going to be 2x. That's the way these inscribed angles work. The angle is half the arc, 1/2 of the arc. Angle, half arc. Angle will be equal to half the arc. Okay? This is for an inscribed angle only. Remember, central angles, they're going to be equal, but inscribed angles, they're going to be 1/2. And so you can use that to help you with some problem solving. Here's an example. What's the measure of this arc right over here? What's the measure of that arc? Well, The angle's 25 that inscribes it. That means this arc is going to be 50. Why? Because the angle is half of the arc. The arc has to be twice as big. That's an easy way to do those type of problems. Here's another one. I've got an arc. It's 90-degree arc. What is the measure of this angle over here? Well, to find this, I'm going to take half of 90. That's 45 degrees. 1/2 of 90. You guys seen how I'm doing those? Okay? So, this is a corollary. And the corollary says that an angle that is inscribed in a semicircle is a right angle. Well, why would that be? Well, look at this. What is this arc down here? This arc right down here is 180 degrees. If that arc is 180 degrees, the angle that inscribes it, which would be this angle right up here, is going to be half of that 180 degrees, or 90 degrees. So yeah, I can see that if I have a semicircle, I have a 90-degree angle. And that becomes easy for us to use a semicircle to get a 90-degree angle. Okay? So looking at this one, if I have two inscribed angles that intercept the same arc, notice that this arc, AB, is being inscribed by two different angles. This angle over here and this angle over here. Well, since this is the same arc, I take half of this arc, and that's what this angle is going to be, and that's also what this angle is going to be. These two angles are congruent angles. They have the same measurement. That's a corollary. You don't have to prove corollaries. You just have to, basically, you can look at it and say, well, that's obvious. We don't have to prove that one. That's what this is saying here. We're not proving this. We're just showing you these two angles are going to be always congruent to each other. Okay? So looking at this one, they're asking, what's the measure of angle X? Right here, X. That we're wanting to find the measure of this angle. Well, you know what? I'm noticing that this arc out here that I just drew on the screen, this arc is inscribed by this angle over here that's 22 degrees. That makes this arc 44 degrees, and that means that half of this is 22. That means this angle over here must be 22 degrees. That's how you can use this, okay? It's one of those cute little tricks that gets used, and a lot of times surveyors use this, a lot of time other people use this over and over again to make certain they've got the correct angles. Okay? So, this is a more complicated problem. Let's look at this one. It says, what is the measure of angle X, right here, in this figure that's shown here? Well, you know what? I can see that X has this arc that it's using, right? That it inscribes. That means if I could find the measure of this angle over here, X and this angle would be the same thing, right? But I don't have that angle. I've got this angle 40, and then I've also got this angle 95. I remember back in one of the first units that we did in geometry, we talked about vertical angles, where two straight lines cross each other. The angles that are opposite each other are congruent. So that one's going to be 95 degrees up there too. And I know that triangles add up to 180. So that means I've got 180 is equal to 95 plus 40 plus the angle at A. And if I add these together, I get 135, and subtract that from 180, I'm going to get, what am I going to get? 45, and I'm going to get 45 degrees, aren't I? Is equal to angle A. That means that X down here must be 45 degrees as well. You guys see how I got that? Okay? And I'll just move that out of the way and show you that I got the right answer. Cool? Okay. I do appreciate the fact that you guys are letting me know that you are in geometry and what section of geometry you're in, because when you let me know that, it allows me to find your information a lot quicker and then respond to your questions about things a whole lot quicker. So make certain you always tell me what grade or what section of the course you're in. Okay, I appreciate it, and I will talk to you next time.